So today's learning target is going to be solving equations. We're going to solve equations that look like this, where there's parentheses in it. So we're going to have to do a little bit of work to simplify. And I'm going to give you guys what I think is the 3 steps, fail-proof steps to simplifying equations. If you remember to do these 3 things before you start solving an equation, your life is going to be so much easier. You're going to save yourself time and energy. Less steps means less opportunities to make mistakes, so you're probably going to be more accurate as well. And I'm going to write them right up here at the top of the page. 3 things you should always do before you start solving equations. Number 1, get rid of parentheses. If there's any parentheses in the problem, which we haven't seen yet, but we're going to start seeing it today, that's your first order of business. You want to get rid of those parentheses. We now have some tools for doing that, so that's the main thing we'll be doing today. Number 2 is combine like terms. If you have some stuff on one side of the equation that can be combined together because they've got the same variables, or no, they both have no variables, combine those together first. Before you start adding or subtracting from both sides, try and combine anything together that you can. And then number 3, this is the one that a lot of times people will forget before they start solving. You only want x's on one side. If you've got x's in 2 different places, you can't solve for x. You're eventually going to have to get it so there's only an x on one side. So if you do have x's on both sides, you need to get rid of one of them. So I'm just going to run through the warm-up problems. This is right in your packet. Our warm-up problems are at the beginning of the lesson here. So I look through this equation. I don't see any parentheses to deal with, so step 1's good to go. I don't see, on this side, there's no like terms. We can't combine those. Same thing over here. So, we're not ready to get started. I forgot step 3. Are there x's on both sides? Yes, we got to deal with that. Either I get rid of the 8x or the 5x. It doesn't really matter. I'm going to choose to get rid of the 5x. It's a positive 5x, so I'm doing minus 5x on both sides. Gets me 3x over here. Still have my minus 7 equal to 11. And I've done all my simplifying now. It's a simple 2-step process. We'll add 7 to both sides to get 3x equals 18. We'll divide by 3 on both sides to get x equals 6. All right, were you guys able to get 6 for that one? Woohoo! All right, let's look at this next one. Ooh, I do see some like terms we can combine. Did you all combine your like terms before you started solving? 3x and 2x combined makes 5x. Over here, that's a 1x, and I'm going to combine that 2 and the negative 25. So 1x, 2 minus 25 is negative 23. All right, we're taking care of combining like terms. Got x's on both sides. We don't want that, so let's get rid of, I'm going to get rid of the 1x. Minus 1x on both sides gets us 4x. And now we're done simplifying. We just get the x by itself. So minus 9 on both sides. And divide by 4 gets us negative 8. Any questions on that one? All right, part C, this is a little bit new. Would you guys feel okay on this one? Did you do what the problem told you? Well, first of all, let me ask you a question. Can I combine this 1x squared with this negative 8x? Can I put those together? I cannot. They have the same variables, but they don't have the same exponent. You can't combine stuff if the exponents are different. So I cannot combine anything over here or over here. My hint to you in the little box there was do minus 1x squared on both sides. Minus x squared on both sides. That means this one's going to go away and this one's going to go away. And now that looks an awful lot like part A, doesn't it? We've got x's on both sides, but we know how to deal with that. In fact, I'm going to deal with it right here in this same step. Do y'all want to get rid of that negative 8x or the negative 6x? We can't keep them both. Let's get rid of one of them. You want to get rid of the negative 8x? Okay, so we'll do plus 8x this time so that those cancel. So that just leaves a 12 over here. Negative 6x plus 8x is 2x. We still have a negative 4 over here. That's not too bad. From there, I'll let you finish that up if you haven't already. I think we're going to get 8. Does that sound right to you guys? Yeah. Any questions on that one? You're going to see some problems that have x squareds in them today, but just subtract it from both sides and it'll go away. Now, it's not always going to happen where they both go away completely. We'll deal with when that doesn't happen at the end of the year. Probably in May. Part D, I want to show you like a method for solving these, but for right now, the hint told you there's 2 solutions. Give me one number I could plug into this absolute value and get a positive 10 out of it. Say again? I could put negative 10 in there. Because if I put negative 10 in there, the absolute value of negative 10 would be positive 10. Give me another number that I could put into an absolute value and get a 10 out of it. Positive 10. And that's it. Those are my 2 solutions. We'll be solving equations with absolute values on Tuesday. And that, my friends, will be our last lesson of the year. Like, of the calendar year. But also the last lesson of the semester. We're wrapping it up when we come back from Thanksgiving break. We'll be reviewing and doing a little preview after that. All right, guys, let's get into our new stuff for today. So we now are going to be solving equations that have parentheses in them. And the trick to this is to get rid of the parentheses. And the way we get rid of the parentheses is by doing what we learned last week. So we're either going to do distribution or we're going to make a box and multiply things out, depending on which method you preferred. So I'm a distribution enjoyer. That's what I'm going to do here. I have one thing sitting in front of a parentheses with 2 terms, so that 4 is going to multiply by everything inside of there. And in the same step, I'm going to do the same thing with this negative 3. It's going to multiply everything inside of there. So see if you guys can write down the first step on your own. Practice this if you remember how. If you can't remember how, I'll walk you through it up here. But you're going to get a lot more out of this by trying it on your own than just copying my work. So we're multiplying these. This times this is that. I'm going to multiply here. This times this is that. I'm going to multiply by negative 3 here. And I multiply by negative 3 here. I think that's going to make it a positive, so that'll turn into a plus. And we should end up with that. And then from there, we know what to do. Combine like terms if you can. I don't think we can in this one. Got x's on both sides. We don't want that. Go ahead and deal with that next. Let's get rid of my 8x or 6x. I think I'll get rid of the 6x. If you chose to get rid of the 8x instead, that's fine. We're going to get the same answer. And then get at the x by itself. Again, go ahead and finish this up. You guys know how to do these. Don't just copy what you see on the screen. Not too bad, right? It's kind of just one more step from what we've been doing. We just got to get rid of the parentheses first. It does get a little tedious with what we're going to do on the next page, but let's enjoy it while it's nice and simple for now. So go ahead and try that next one on your own if you're feeling confident. You've got another couple sets of parentheses. They both have something out in front. So we're going to distribute the thing out in front. This time you will have this 14 that's going to come down, and I think you'll have to do some combining like terms here. I want to work through it silently up here, but I encourage you to try and do it on your own without looking at the screen. Just take a peek up here if you need a hint, though. I also want to take this opportunity to remind you how simple and quick it is to check and make sure that you've done an equation correctly. I'm copying down the original equation and leaving out all my x's. I'm going to go back and put a -2 in for each of my x's. We'll see if this thing works out. It only takes a moment. Well, hello, these Eagle Time people. Oh, no, this is first period. Okay. I will get them passed out. Thank you. Okay. Let's see here. Inside of the parentheses is a -7, so I got -2 times -7, which is 14 on that side. Inside here, I got 2 times -2, which is -4 plus 4 is 0. 3 times 0 is 0 plus 14 is 14. There we go. It works. Sorry, I had that off the screen, but start to finish, maybe 30 seconds tops for me to check and see if that equation's correct. Are you going to do this on every single problem you do on your assignments? Probably not. Should you do it on every problem you have time to do it for on a test? Absolutely, yeah. Yeah, if you have an opportunity to know whether a problem's right before you turn in a test that's worth a large chunk of your grade, then take that opportunity. Okay, a couple more. You guys are doing awesome. Any questions on that first page before we go on? I did warn you, these ones get a little tedious. It's all right, bless you. We got it, though. You all have been practicing this, those of us who've been doing our assignments, so the tedious part's going to go pretty quickly for us. When I do this problem, I am going to distribute this 2x. That's going to be pretty simple. What's going to be a little bit more time intensive is figuring out what this whole mess is equal to. And I'm going to do some work off to the side for that. So I've got a binomial and another binomial, 2 terms and 2 terms. So we're going to need to do that whole box thing. Unless you do the double distribution method, which I'm fine with. I like the box, so I'm going box. So a reminder, if you were absent when we went over this last, would have been Thursday, our 2 binomials go on the top and down the side. It doesn't really matter which one goes on the top and which one goes on the side. I'm going to set it up like that. I could have put the 1x and the 3 on the side and the 2x and the 4 on the top. Just don't mix and match them. And then this is just like a multiplication table. To figure out what goes in this box, I multiply the 2x times the 1x. 2 times 1 is 2, x times x is x squared. To figure out what goes here, I multiply the 2x times the 3. 2 times 3 is 6, and we've got a single x, so that's just a 6x. Here I'm going to multiply 4 times 1x, that's 4x, and here I'm going to multiply 4 times 3, that's 12. And then that is going to go over here. All that stuff on the inside. And I think I can do some combining here. I think that 4x and that 6x will combine together. We'll just call that 10x when I write it down here, the 4x and the 6x. So that's a 2x squared. We got 4x and 6x is 10x, positive, so it gets a plus. And 12 is also positive, it also gets a plus. That takes care of that side. Now we got to distribute over here. 2x times x, that's 2x times 1x. 2 times 1 is 2, x times x is x squared. 2x times 6 is 12x. And there, all that work just to get rid of the parentheses. But from here, it becomes pretty straightforward. We got a whole bunch of x's in here. We need to start getting rid of some of them. We have multiple x's on both sides. The thing that I like about this problem, it's got 2x squared on both sides. Let's get rid of those. Then they both go away, right? We could do minus 2x squared. We got to do the same thing on both sides, but when we do it on both sides, it gets rid of both of them. Are we still going to have x's on both sides? So while we're at it, let's get rid of one of those too. Y'all want to get rid of the 10x or the 12x? 10x, okay. It's positive 10x, so let's do minus 10x. It leaves us with just a 12 over here and a 2x over here. Oh my gosh, that's not too bad. Divide on both sides, and we got x equals 6. And if I wanted to, I could plug that in really quick and check to make sure that the equation's right. All right, there are 3 more problems on this page, but I'll tell you what, if you can do number 4, then I'm happy, because it's the hardest of the 3. Now, I'm going to warn you, on number 4, you are going to have to do the box, and you're going to have to do it twice. You have to do it once for that side of the equation, you're going to have to do it once for this side of the equation. So that's why I left you some space off to the side, because you're going to have to do some side work on that. So give that a shot. See what you can do with those. Let me know if you need some assistance. I'm going to freeze my screen and work through it, because I really want you to try. But I'll put the answer up here in just a moment. Yes? Mm-hmm. The square? Yeah, so that's a good question. Just in case anybody else is thinking the same thing, I'm going to do it up here. Thanks for asking. The question was, when do we put the exponent of 2 on here? So when I filled this out, I always, when I'm multiplying and I got stuff with numbers and variables, I do the coefficients first. So in my head, I did 2 times 1 and got the 2 here. And then I did the x's, x times x. And it's that x times that x that got me that x squared. So I always think through, when I'm looking at these, I ignore the x's for my first pass, multiply the numbers together, and then look at the x's. And since there's 2 x's being multiplied, it was an x squared. Now on this one, I ignored the number, or ignored the variables, looked at the coefficients. We got 2 times 3, that gave me the 6. And then I noticed there was only 1 x here. There wasn't an x on this one. There's just 1 x, which is why I did not square it there. Does that answer your question? That's an excellent question. Thank you for that. So yeah, when you're multiplying, kind of do it a piece at a time. You're going to eventually see some of these where there's x's and y's and coefficients. But it's not any harder, because you're going to just look at the numbers first, and then you'll go through and do the x's, and then you'll go through the y's, and then you'll do the z's if you got to. Just one piece at a time. Divide and conquer. Any other questions on that problem? Thank you for that. That was a great question. I appreciate that. All right. I'm going to freeze the screen and work through this. Let me know if you've got questions, if you need a hint to get you moving here. I think this one may come out with a fractional answer, folks. That's okay. I don't know why, I've just got a feeling. Unless I made a mistake someplace. I better check and make sure that's right. Yes? No? I have a feeling I made a mistake someplace. I don't know why. Did you? Hey, let me show you something while you got your calculator out. This you're going to love. Okay. Type in negative 17 divided by 9. Some of the other calculators will do this too, but the graphing calculators do it. And then there's this stow button down here. Hit that, and you'll get a little arrow. And then use the X button. It's right next to the alpha. XT theta n. Yeah? You got it? And hit enter. So that you just stored this value in for X. Okay? Now I'm going to type in this side of the equation. So parentheses 3X. And I'm typing it in with the X because I stored the value of X in the calculator. It's going to use that negative 17 over 9, and it'll automatically do the plugging in for me. And I'll hit enter. All right, remember that number, where I'm hoping when I plug in this side of the equation, I get the exact same thing. If I do, that means we did it right. So this is basically like what I showed you. Hey, you can check your answers by plugging it in. We're just making the calculator do it for us. Yeah, I think it is. That's the right answer. If you have these blue and white calculators, those also have a stow button on them. It's down right above the on. So if you have one of these, you could type in negative 17 over 4, or what was it? Over 9, divided by 9. Don't do it as a fraction, just do it as division. And then stow it, and then your X button is right above it. Stow it in for X. And then you can type in both sides of the equation and make sure they come out to the same thing. So I could type in parentheses X plus 3 and 2X plus 4. So it's even easier if you've got one of these calculators that'll allow you to store numbers. They don't all do that, but these ones do. Oops, I typed that in wrong. I don't know where I got 2x plus 4. I was looking at something else. Oh, I was looking up here. Anyways, I plugged my answer for this one into this. That's what I just did. That's why it's not coming out the same. Anyways, that's it, guys. We are just solving equations, except now we're just adding one more step at the beginning. Get rid of the parentheses. We are getting into what I would consider some real deal algebra when we start doing this. These are some pretty complex equations. There's a lot of steps to solving them. Believe it or not, it's going to get more complex than this when we get it in the second semester. In the second semester, so you have an idea what's coming up, we're going to be solving these things called systems of equations. And in these ones, we're not going to solve one equation, we're actually going to solve two different equations at the same time. So instead of me giving you one equation that looks like this, you're going to get two equations. They're both going to have x's and y's in them. So when we solve, we're not just going to get x equals something. We're going to get x equals something and y equals something. And there's some very simple processes for doing it. I'll show you 3 different methods. Once you learn those methods, you're going to be good. It's not difficult. It's not difficult. They do take a little bit longer, but I won't be assigning nearly as many of them because of that. However, you want to be pretty strong with this stuff. You want to be pretty strong with solving equations where there's only one equation and one variable before we get into that. So use this as an opportunity to really practice and strengthen those skills so that you're ready to go when we get to systems. All right. Guys, let me get the assignment to you, and I think